So we're going to go over some exponent rules when we have quotients involved. The first one here is the quotient rule for exponents. When we have a base raised to an exponent divided by the same base raised to an exponent. To simplify that, we could keep that base the same and then subtract the exponents. So for example, if we had x to the power of 7 over x to the power of 3, we would keep the base of x the same and then subtract the exponent. 7 take away 3 leaves us with 4. Okay? Another example of that, what if we had x to the power of 3 divided by x to the power of 7. So I use the same numbers here. When we subtract these though, if we do 3 take away 7, that's the order we should do, then we get x to the negative 4. There's two different ways that we can represent this. Depending on what we're looking for, x to the negative 4 might also look like 1 over x to the 4th. And then one more thing always to keep in mind is that when we have a number to an exponent, but if we don't see an exponent there is always technically an invisible 1. So right now I have x to the power of 3 divided by x. Remember, that's the same as x to the power of 3 divided by x to the invisible 1. So to use our rule here, we would take our 3 minus 1 to leave us with x to the 2. The next rule that I want to look at is the power rule for quotients. When we have our exponents on a fraction and then we raise that to a fraction, we want to make sure we multiply both the top and the bottom exponents. So for example, if that was x to the 3, x to the 3, and maybe y to the 2, all raised to the 4. Our rule tells us that we want to keep x to the 3 and then multiply it by the 4. In the denominator, we're also going to keep our y squared, but then multiply that again by the 4. So to simplify this, that would look like x to the 12 over y to the 8.